right, class. We're going to begin doing our Chapter 3 practice test just so that we can get through this. Let's start with line FE. FE is right here. We want to look at a line that's parallel, so I'm just going to pick AH. There were also, I could have picked GD, or I could have picked BC. But I chose AH. Number 2, a line that is perpendicular to CD. So here is CD right here. I want it perpendicular, so I'm really going to look for a line that either forms an intersection with C or D. So for this case, I'm going to pick line BC in my cube. That works. I could also pick HC. I could pick ED, and I could pick GD. Now, for number 3, we're looking for a line that is skew to BC. Here is BC. I do not want it to intersect at all. I do not want it to be parallel, and I want it to be on a separate plane. So I'm looking over here, back here. I see that HE is not parallel with it. It is not intersecting it, and it is on a different plane. So I'll pick that. There are several others that we could pick. We could pick DE. We could pick GF. We could pick AE. So there's several there that we could pick that would also work. Now I need a plane that is parallel to BCG. So here is BCG. So it's this plane right here. I need one that is parallel to it. Like a shoebox, I'm just going to pick the back of it. I'm going to pick AHF. And there we have it. Moving on, problem number 5. Angle 3 and angle 6. Looking at those, 3 is here, 6 is here. Those are alternating interior angles. Okay? Angle 4 and angle 6. I notice they're on the same side as the transversal, so they're consecutive, and they're interior, so interior angles. Angle 2 and angle 7, I notice that they are exterior and that they alternate the side of the transversal, so alternating exterior. Number 8, I'm looking at angles 4 and 5. Notice that I switched sides of the transversal, so they are alternating. And these happen to be interior. They are inside the two lines that we are comparing, so alternating interior. And our last one, angle 1 and angle 8. Notice I alternate the side of the transversal, and they are exterior, so those are alternating exterior. All right, let's move on. Number 10, it says to find the value of x. So the first thing I notice is that this angle right here is 90. This is a straight line right here. Therefore, I'm going to assume that this angle right here is 90, but it's made up of 2 parts. The first part being x plus 15, and the second part being 3x minus 17. By the angle addition postulate, if I add those together, I should get the whole. And the whole is 90 degrees. So I will do that. So then I get 4x plus a negative 2 equals 90. Add 2 to both sides. 4x equals 92. X equals, 23. And there you have it. 11. I'm still solving for x. I notice here I have an exterior angle, and here I have an interior, and they alternate. But I don't have a theorem for alternating exterior-interior angles. But what I do notice is that right here, if I knew this angle, I would actually have consecutive interior angles right here. And when I look at this angle, I recognize that it is vertical to this. So the measurement for this angle is the same as that because they are congruent. Vertical angles are congruent. So I'm going to write that down. And now that I know both of those angle measures in terms of x, I know that they are supplementary. That means they add up to 180. So I will take angle x degrees and add it to 1/2 x plus 15. And because they're supplementary, they equal 180. I am going to times all of this by 2 because I don't like this 2 on the bottom. I want to get rid of it. So 2 times x is 2x. 2 times 1/2 x is just x. 2 times 15 is 30. And 2 times 180 is 360. Combine like terms. And I end up with 3x equaling 330 and x equaling 110 degrees. When I take it back and check it, sure enough, I get 110. This turns out to be 70. 110 plus 70 is 180. Number 12, I just need to identify what kind of angle pair relationship I'm looking at. So I'm looking and I notice that they're on the same side, so they're consecutive. And they're both interior. So 12 is consecutive, interior angles, and that's how I would prove the lines are parallel, so I need to make sure this says converse. Okay? Number 13, if I were to prove L and M parallel, looking at these, I have alternating exterior angles. My signs say that they are congruent, so I would use alternating exterior angles converse. Once again, I'm proving lines parallel. We'll put that LM up there so we know. Just said, how would I prove it, or what postulate or theorem could I use? Those are the postulates and theorems. 14 and 15. If we look at that, we are being asked to do something with 14 and 15. And it looks like it asks on 14 to tell us whether they are supplementary or congruent. So 14 had angle 4 and angle 6. So if I look at 4 and 6, I notice that there are consecutive interior angles, and I know that they are supplementary, so I'm going to write sup. We're supplementary. 15, it wanted me to look at angles 1 and angle 8. 1 and 8 are alternating on the transversal. They are exterior. Alternating exterior angles are congruent, so I'm going to say they're congruent. It would be okay if you just put the congruent sign. All right? 16, 17, and 18, I'm given a graph. It's asked me just to find the slope, so I just need to find the slope. I'm going to remember this formula right here for all 3 of those, that the slope, get this over here, slope being m is equal to y2 minus y1 over x2 minus x1. I already have mine written in a form that they're just kind of stacked. My y2 is 2 minus a negative 6 over 2 minus negative 2, which gives me 8 over 4, which is equal to 2 over 1, or 2. So my slope is 2. On 17, do the same thing. A negative 2, subtract 4 over a negative 6, subtract 6. That is a negative 6 over a negative 12. Those negatives cancel out. I'm left with 1 over 2. And my last one, I have 1 minus a negative 1 over a negative 2 minus 5. That leaves me with 2 over a negative 7. They do not reduce down. Therefore, my slope is 2 over a negative 7. Or up to, or down to, over 7. All right, 19, 20, 21, and 22. I'm looking at 2 lines. I'm comparing their slopes. I need to choose if they are perpendicular, parallel, or none of those. So I'm going to look at just the slopes. These are already in the slope-intercept form. So all I need to do is look at the coefficient on x. This one's 4. This one's 2. They are not equal, so they are not parallel. They are not the negative reciprocal of each other, so they are not perpendicular. So on 19, they are neither. On 20, I look at the 2, and I look at the negative 1/2. I notice that they are the negative reciprocal of each other. I can test that just to make sure. 2 over 1 times a negative 1 over 2 equals a negative 1. These lines are perpendicular. I'm going to put perp, and then I'll just put the sign so you know. 21. Once again, I'm looking just at the coefficient on the x. I've got 5, and I've got 5. The slopes are equal, therefore I know the lines are parallel. Or I could put parallel like that. And our last one for this is 22. I have a slope of 2. I have a slope of a negative 1/2. Once again, they look like the negative reciprocal of each other. I'll test it 2, which is really 2/1 times a negative 1/2. These will be with a negative 1. Therefore, they are perpendicular also. And I'll leave the sign for perpendicular. Erase that. And our last problem, 23. We need to just fill in the blanks for this proof. The first statement is always the what? The given. Pretty easy, given. Now my clue comes from the reason on 2 for the next one. It's talking about vertical angles. And if we looked at our picture on this, I'll just quickly draw it right here. It looked like this. And I believe this was 1, this was 3, and 2 here. And it's telling me, talking about vertical angles. Well, the only pair of vertical angles I see are 1 and 3. So I'm going to put angle 1 is congruent to angle 3, and I know that because that's the definition of vertical angles. We know vertical angles are congruent. Then using transitive, angle 2 congruent to angle 1, angle 1 congruent to angle 3, therefore angle 2 is congruent to angle 3. That was transitive. And now I'm ready to prove by corresponding angles. I've got 2 and 3, they're corresponding angles. Angle 2 and angle 3 are corresponding. That means that line L is parallel to M, and that was corresponding angles converse. Thank you.